Hi everyone, thanks for joining us for this webinar. My name is William Brander and this is Sean Farmar.
Hello.
We're solution architects working for particular software, and for the next 40 minutes or so we're going to be talking to you about what to consider when monitoring your microservices. By way of an agenda, we're first going to introduce you to some basic concepts, and then we're going to present a philosophy on monitoring, which should hopefully equip you with a way to think about the actual value of the information that you're monitoring. We're then going to take a look at how things change when you distribute them and start heading towards a microservices space. And then we're going to finish off by looking at 5 specific metrics that are very valuable when working with distributed systems. We have a slot for Q&A at the end, but please feel free to ask questions throughout the webinar as we go. We'll get around to answering them at the end, and if we don't answer your question during the webinar, we'll reach out to you afterwards and provide you with the answer. So without further ado, let's set the scene. Here we've got a simplified view of what could be considered a fairly average production system. It might be a single application server or a web server talking to a database, or you could have a couple layers of servers between there talking to a shared database. Maybe if this is a Microsoft stack, you'd have a MVC application talking to an application server, either over WCF or REST or something like that. And that application server might talk to the SQL database via an ORM, say Entity Framework. I'm sure you've all seen systems like this in the past. Now, these types of systems are fairly self-contained within their own ecosystems. So if all of the pieces are available and functioning, then the system should be okay. And that's kind of a good start to try and monitor a system like this. So you might ask a set of questions. Is the server up? Is the database up? And can the web server talk to the database? And that's a fairly decent start to monitoring the system. And if the answer to all these questions is yes, the components are probably working. The question is, though, by asking these questions, what are you actually monitoring? So by asking the question, are my servers up? That's specifically monitoring the infrastructure of your systems. Now, whether the question is about physical servers or Docker containers or Azure worker roles, the question is still specifically talking about the infrastructure that your applications run on. If instead we had asked, is my application process running? This means that we're now monitoring the application level of our system. And if we change the question again, we can ask something like, can users access the system? And now this question isn't talking about infrastructure or the application service. This is talking about a business capability. Is this business capability available? We could make this even more specific. So as an example, if we had an Amazon type application that we were working on, we might ask the question, can users access their shopping cart? Where the shopping cart would be a specific piece of functionality. And what we can see here is that by changing the questions that we ask, we effectively start monitoring different areas of our application. So remember that a business capability can be split across multiple applications. And each application could also be split across multiple infrastructure pieces. So we've got these 3 layers. And each of these layers talks to a specific monitoring area, where the types of questions that we ask mean that we monitor slightly different areas of our system. But there's another element to this. We can also introduce similar layers to help find out the different attributes of our system. So we might ask questions that would highlight the health of our system, the performance of our system, or the capacity of our system. And specifically with the right questions, we can get information about the health, the performance, and the capacity of our infrastructure. The same is, of course, true for the application level. We can ask specific questions about the health, performance, and the capacity of our applications, as well as the business capability. And in fact, there's a many-to-many relationship between each of the pieces of the monitoring area and the monitoring concern. Let's take a look at a few examples to see what I mean. So by asking the question, is the server up? We're effectively asking about the health of our infrastructure. If I change the question to, is there high CPU usage? That's talking about the performance of the infrastructure. And do I have enough disk space? Is talking about the capacity of the infrastructure. And in fact, all 3 of these questions deal specifically with the health, the performance, and the capacity of the infrastructure that I'm dealing with. A different set of questions that would look at the health, the performance, and the capacity of the application could be, is my application generating exceptions? This would talk to the health of my application. Or how quickly is my system processing messages? Would talk to the performance. And can I handle my big month-end batch jobs? Would give us a view of the capacity of our application. And similarly, we can ask a different set of questions to investigate the health, the performance, and the capacity of our business capability. Can users access the system? Are we meeting our service level agreements? And what is the impact of adding another customer? That last question would be particularly applicable in the case of perhaps a software as a service company. So hopefully you can kind of get a view for how each layer of the monitoring area corresponds to multiple layers within the monitoring concern and vice versa. There's a many-to-many relationship here. But it gets a bit more complicated than that though, because not only do we have a monitoring area and monitoring concerns, we've also got interaction types. And in this pyramid, we've got passive monitoring, reactive monitoring, and proactive monitoring. So we're talking about how we monitor the system. Passive monitoring is where you monitor, where the monitor can give you the status of a metric. So you ask, what is the current status of, and it shows you. Reactive monitoring is where the monitor can alert you when specific conditions are met or when something happens. Proactive monitoring is where the monitor can also automatically try and fix a problem when it occurs. So an example of this would be spinning up a new workup process in Azure if the monitor detects that the throughput is running a bit low. So each of these layers also correspond to the existing many-to-many relationship. So we end up with a multi-dimensional relationship between the monitoring area, the monitoring concern, and the interaction type. And this is all well and good, but how do we use this? So the monitoring philosophy is a tool that helps you classify what you're monitoring. And then you can, once you've classified it, you can decide whether or not that's meaningful. So let's go back to our average system example. By monitoring the status of the servers and the network communication between them, it should be clear that we're monitoring the health of the infrastructure. And because typically when you do this kind of monitoring, it's on an ad hoc basis, it's more than likely in a passive manner. So for our average production system in our example, we were doing monitoring of the infrastructure, the health of the infrastructure in a passive manner. And in a self-contained system like this, that kind of monitoring might be enough. But things change when we move to microservices. So Sean's going to talk you through how things change when you start taking those first few steps into distributed systems.
Oops, glitch there. Yeah, so let's look at the simple scenario. We have a layered architecture with a tier deployment, and we have a high I/O operation like sending emails. We want to move the email functionality to its own component or its own service. So we can send a message from our business logic code in an asynchronous fire and forget operation to improve performance. Next, we can do the same for our PDF converter functionality. And to expand on that, we can now add some integration to our CRM system, synchronizing events from the business logic code and our CRM system using publish subscribe. So from a layered architecture with a tier deployment, having a web tier and a database tier, we now have a much more distributed system, a couple of processes and servers talking to each other using queues and messaging. We also introduced publish subscribe for integration with our CRM. We can see how microservice style deployment, whereby services has kind of its own database, pictured as those little round things. Regardless of the physical deployment, you want to monitor all the different components of the system and the flow between them. So now we have distributed our system. We added a couple of processes, and we added a queuing mechanism. There are certain elements of queues and messaging that should be monitored. These elements are different from traditional web-based environment using HTTP REST messages. We want to monitor the time it takes for a message to be processed end-to-end. We have a couple of metrics we can look at. Let's start with the queue length. Most queuing systems have some kind of functionality to monitor queue length. Here are some examples from Azure, MSMQ using performance counters, and RabbitMQ. Queue length is a measure of how much work is outstanding for each endpoint. A high queue length is only a problem when it is increasing. We want to consider our disk capacity as messages in a queue are persisted to disk. Let's look at how we measure processing time. Processing time is the time it takes for an endpoint to process a message once a message has been taken off the queue. This excludes all DQ operation time, meaning that the counter starts once a message has been DQ'd, deserialized, and handed over to the handler code. Once the handler completes the execution of the code and returns, the processing time counter is stopped. Processing time does not include error handling or retry times. So what do we do when there are errors? When using durable messaging, we can avoid losing any data by using retry mechanism in case of an exception. If all our retries fail, we move the message to the error queue. Let's see how that works when we're using N-Service Bus. We may run into temporary issues like resource contention. For example, a deadlock in our database. This can be resolved by retrying to process the message immediately. We can do a number of retries, and if the issue does not resolve itself, we go to delayed retries. Delayed retries deal with network connectivity issues like a call to a remote API. This can be resolved by waiting for a while and then trying again. In each time we try to process the message, we do a cycle of immediate retries. We may have a permanent issue, like a bug in the code or a configuration issue where we put the wrong connection string or the wrong file share address or something like that. In this case, after all retries have failed, the message ends up in the error queue. Note that while the retry process is automatic, once a message ends up in the error queue, we need a human to look at the error's stack trace, fix the issue, and then return the message to the original processing. We mentioned network connectivity. Let's look at how we can do this when dealing with messaging. William?
Thanks, Sean. So Sean has just shown us 3 metrics we can use to monitor the behavior of a message once it gets to an endpoint. We can see how many messages are in front of that message in the queue by using the queue length. We also have a good idea of how long it's going to take to process the message because we have the processing time. And we also know that with the automatic retries, we can see how many failures it had to go through before it's going to succeed. But given that distributed systems are designed to continue working if destinations aren't currently available, how can we monitor if there's actually connectivity between endpoints in the system? And even if we know that there's network connectivity between 2 endpoints, how can we be sure that the endpoints that we send in a message to are actually processing the messages? So we can do this by doing connectivity checks between endpoints. Now, you might think a good approach here would just be to do network pings, maybe see if the destination server is going to respond. Well, that might work, but the destination server could be stuck in a loop where it's actually not processing messages. So it's responding to network checks, but it's not processing any messages. So how do we check that the endpoint is both available and processing messages? Let's take a look at one possible way. So if we assume we have an endpoint that wants to send a message to another endpoint and there's a network failure between the 2 endpoints, the send operation, if it was synchronous, say we were using TCP IP to send the message, the actual send operation would fail if there was a network failure. So immediately the sender would know that there's connectivity issues to the destination. Unfortunately, that's not how microservices typically communicate. Most of them would use reliable messaging, perhaps queuing through a broker, or they might use a federated queuing system that's got store and forward. So this means that the actual send operation doesn't go directly to the destination, it goes through a broker. And the message from the sender gets sent to the broker or gets persisted to the store and forward queue. And at that point in time, the send operation, as far as the sender is concerned, has been completed. So if there is a network failure between the broker and the recipient, the sender has no idea that there's a problem there. So once the network connectivity is restored and the message eventually does get to the destination, again, the sender doesn't know that that has happened. So how do we find out if there's connectivity and if the destination is actually processing messages? What we can do is we can attach a bit of metadata to the messages that we send. And this little piece of metadata would just say to the destination, hey, when you receive this message and you process it, just let me know that you're done. It's like a receipt. So once the receiver processes the message and it sees that little piece of metadata that says the sender wants a receipt, it can generate the receipt and send it back to the original sender. This way, the sender not only knows that the destination point is actually accessible, but that it's also physically processing messages that it's receiving. So it's not stuck in some kind of loop. Now, obviously, you don't want to do this for every single message that gets sent between endpoints in your system, because you turn your beautiful messaging system into a very chatty, tightly coupled operation. And you'll have put async messaging into RPC over queuing, which is a horrible anti-pattern. But perhaps there's a window of time that makes sense for this kind of receipt. Maybe every 5 minutes, just on a message you send after 5 minutes, ask for a receipt. So that you know within a 5-minute window that an endpoint is up and processing messages. Maybe instead of time, it makes more sense to do it on every 100 messages, every 500 messages. Whatever window makes sense for the endpoints in question. What's nice about this, as I mentioned before, is that we're not only confirming that the destination is actually processing messages, but it's also, we're not testing connectivity between the broker and the sender and the broker and the destination. Effectively, what we're doing is we're doing decentralized connectivity checks. So we're doing peer-to-peer processing connectivity checks, and it's a great way to identify hotspots in your system where you might be getting failures. So now that we have a way to check that the destination points are all up and running, and we combine that with the 3 metrics that Sean introduced us to, it might seem like we're going pretty low level here. So maybe there's a way to aggregate some of these metrics together. And yes, there is. So we're going to take a look now at a metric called critical time. So critical time is a measure of how long it takes to successfully process a message. Now, that might sound very similar to the processing time that we had earlier. The difference is critical time includes everything else around the message as well. So let's take a look at an example. Let's say I've got, again, an endpoint that wants to send a message to some destination. As soon as I have a message ready to be sent, a timer that represents the critical time of that message starts counting. So the message hasn't even technically been sent yet, but the critical time has already started counting for this message. The message gets sent across the network, and the destination endpoint can pick that message up off the input queue and start processing it. Only once the message has been successfully processed does the critical timer stop. So critical time is actually the entire time taken to process a message successfully. That includes any network failure time. So for instance, if there was a network failure, as soon as that message was ready to be sent, the critical time would start counting. But now remember, the send operation has completed because we've actually sent that message to a broker, or we've persisted it to our local store and forward queue. So critical time is still counting at this point. Once the connectivity is restored to the destination endpoint, and the destination endpoint can receive that message and start processing it, the critical time will stop only once that endpoint has successfully processed the message. An important note here is that if the processing fails for any reason and the message ends up in that automatic retry phase that Sean described, critical time includes the time spent doing the retries as well. The same goes for if there's messages in front of the queue, or in front of the message. In this example, there's 2 messages in the queue, and each one has its own critical time associated with it. Once the first message is successfully processed, that one's critical time stops. But the second message's critical time is still counting until it gets to the front of the queue and it gets successfully processed. At this stage, the critical time for that message ends. So let's do a quick recap of critical time. Critical time is the total duration between when a message is sent to when it's successfully processed, meaning that critical time includes time spent waiting in the queue, time spent actually processing the message, any retry time that has to happen before that message is successfully processed. It also includes any network time involved. If we look at the typical graph, if the critical time is stable or decreasing, that's usually a good sign. If it's increasing, it's probably a bad sign, and you may need to take action. So we've got 5 different metrics we can use now. We've got queue length, we've got exception diagnostics, we've got processing time, we've got connectivity checks, and we've got critical time. And each of them tells a story about what's happening in our system, but from a slightly different angle. By looking at them together, we can get a better idea of what's actually happening in our systems. And remember, most of these metrics are at a per message basis. So if we aggregate that and we look at it at an endpoint perspective, we can get a lot of insight into what's happening in our system. So let's take an example. So here's 3 graphs. We've got the critical time, the processing time, and the queue length. In this example, we can see that the critical time graph is fairly stable and it's not very high. Queue length is the same. Processing time, while it isn't very high, it is jumping around quite a bit. So what does that tell us about what's going on in our system? Well, if you've got processing time that's jumping around, it might mean that when it's successfully processing a message, it might be calling out to a resource that responds at random times. It might take 5 milliseconds for the first message and 500 milliseconds for the second one. So there might be some external web service that's not responding in a uniform time. Another reason for the jumping could be that certain message types could take longer to process than others, which will give you a clue as to which message types in your system you can try and optimize. You can even try and move those message types that take long to process to their own handlers. Looking at another example, if we've got high critical time and high processing time, but here the queue length doesn't look too bad. The queue length isn't decreasing though. It's not very high, but it's not decreasing. And this is quite a telling scenario because it shows that the endpoint is able to keep up with the number of incoming messages. It means that if we get 5 messages per second coming into the endpoint, we're processing roughly the same amount, 5 messages per second. So we're keeping up with capacity. But what if something goes wrong? What if one of those messages that we're busy processing happens to go into the automatic retry phase? As soon as that happens, the queue length is going to increase because we haven't processed that message on the first attempt. If queue length increases, critical time is going to increase, which means that we're going to start getting closer to breaking our service level agreements. So a situation where you've got graphs like this is a good indication that an endpoint can be considered for scaling out. This is actually pretty much a no-brainer if you're in Azure. If you see this scenario, scale up the worker processes on your endpoint. Scale that endpoint out and let it process more messages more quickly. Here's another good example. So we've got a relatively high critical time, but that's not reflected in the processing time or the queue length. Both of those are fairly low. So what's going on here? Remember that critical time includes processing time and it includes queue length. Those aren't high, but critical time is. Critical time also includes any automatic retries as well as any network traffic time. So we can see by critical time being high, we might have to go and look at the connectivity graph to see if we've got connectivity between endpoints, reliable connectivity between endpoints. If we do, that's a good indication that we've got automatic retries that are continually taking up a lot of time. So maybe we've got table locks on a database table. And in this scenario, it might make sense to refactor some of our SQL queries so we don't get those table locks. But dropping those table locks, you end up preventing the automatic retries, which means that your critical time goes down. So this is a fairly good scenario that will show things that are happening in your system that aren't necessarily reflected in queue length or in processing time. So to summarize, we've got 5 metrics that we've shown you, and each gives you a slightly different bit of information about how your system is behaving. If you combine these metrics, that allows you to see a bigger picture of what's actually happening in your system and where you might have potential problems coming up. Now, you don't necessarily have to focus on absolutely everything that's available in the system. Remember that you've got the monitoring philosophy that can guide you. So the monitoring philosophy, it's a tool to help categorize the types of questions that you're asking about your system. And once you've categorized it, you can then decide whether or not that's important to actually monitor. As a shameless plug, N-Service Bus already provides a lot of these metrics for you. So you don't have to worry about tracking all this information. Just let N-Service Bus do that, and you can instead focus on monitoring the actual metrics that impact your business. So how many sales are we doing? What's the total value of all the transactions we've done, etc. If you'd like to learn more about the content we've covered today, you can, and you haven't used N-Service Bus before, please give N-Service Bus a try, including the rest of the particular service platform. So N-Service Bus, straight out of the box, includes all of the automatic error handling, all the retries, everything that Sean described there. And on the particular service platform side, Service Pulse, Service Control, and Service Insight all give you error queue management that you can use as well. It's well worth looking at if you haven't played with it before. If you have already used N-Service Bus, we've got a package, a NuGet package called nservicebus.metrics. And this package tracks all of those metrics that we've covered today and exposes them as performance counters for you to use. And because it exposes it like that, you don't even need a special tool to display these metrics. So you can see them in Perf1. Or if you do have a tool, maybe using Kibana or Grafana or whatever tool you'd like, you can use that. Even a console application would work here. As a bit of a teaser, this is only the first webinar in the series on monitoring that we'll be presenting. So where this webinar was mainly theoretical, the next one will be focused on a lot more practical. So there'll be a lot more code there and configuration on how to actually do the monitoring. So follow us to find out more about that. And with that, that brings us to a Q&A section. So feel free to ask any questions you have. Remember, any ones that we don't manage to answer now, we will reach out and answer via email at a later stage. Well, one thing I did forget to mention is we will also be sending out an email covering additional content for you probably tomorrow. So you'll get some extra info there. Do we have any questions?
Yeah, William, first question. How do you think that centralized or aggregated logging fits into monitoring in a multi-services scenario?
Centralized or aggregated logging. I've got to think about that for a second. So if you want to centralize your logging, potentially, remember, by taking a distributed system, so you've now moved towards a microservices model, all of your processing sits in a distributed environment. So if you try and centralize your logging, potentially you are going to have maybe a bottleneck there where you're going to bring all of the login information into one central place. It might be better to do maybe aggregated logging at a per endpoint level, per handle level, and then centralize that in an already aggregated phase.
All right, new question. Was this recorded and will it be posted on the particular site?
Yeah, so this recording is like we're recording this right now, and once it's ready, it's going to be posted to the attendees and the whoever registered to the webinar, if I'm not wrong, not mistaken.
Yep. And then another question. Do you have all of these 5 metrics described somewhere in written form?
Yes, we do. They're on our doc site. We'll include links in the email that we send out tomorrow as well.
Justin asks, is the heartbeat designed to be extensible so that additional or custom status or config validations can be easily introduced and represented in the heartbeat statuses?
I think that would suit the, we have something called the custom check plugin, and that allows you to write your own code, and our custom checks will run just like the heartbeats, and they'll be reported in source control. I hope that answers the question.
Yeah, just to add on to that, all of the metrics we've covered today, we haven't really covered any implementation details. So if you want to implement it in your own manner, you can. The custom heartbeats, if you want to use the N-Service Bus one, as Sean said, any custom information you want to send along, we've got additional avenues that you can do that.
All right, we don't actually have any other questions in the queue right now, so Craig actually put in the link for the metrics on our docs site, but we'll be sure to put that in the email. So if you have any other questions, get them in quick. Otherwise, that's it, I think.
Great. Thank you everyone for attending. Please follow us on Twitter, and if you want to reach out to us directly, you're more than welcome to. We'll respond to every single mail we get. Wait, I see we did just get questions.
And there's more questions. I just wanted to mention that both of us are on the chat on the live website, so you could definitely ping us on live chat, and we're available and we're developers out there.
Okay, so this will be the last question. What is the most difficult part of upgrading a system to message queuing?
I'd say it's finding the bounded context. But as we kind of described here, you don't need to go the whole hog in one go. If you do, you take the most critical things, the things that are naturally asynchronous, like sending emails, converting to PDFs, doing some kind of very kind of naturally and asynchronous work, and splitting it out. That could be relatively simple to do, and then slowly starting to carve out the bins functionality that you can compartmentalize or make a good decision about how autonomous this piece of work can be, and then move it out. Hope that makes sense. Anything to add, William?
No, I was just going to say we do have a lot of content on our blog that could help guide people along the better ways to do that kind of process. So maybe I'll send a mail directly to you tomorrow with the links to those blog posts. Okay, great.
I see that there's more questions that are coming. We'll just answer them by email, is it?
Yeah, I think we will answer the rest by email.
Great.
Yeah, and remember, you guys are welcome to email us directly. So if you want anything answered outside of this, feel free to drop a mail. Thank you, everyone, for coming.
Thank you.